So we're here today to talk about something very important. So for starters, I just want to get a quick show of hands. Who in the crowd here has responsibility for OT or industrial control system networks where they work? Excellent, excellent. Good show of hands. Show of hands if you've heard of NOZOMI networks. Perfect. And show of hands if you're just happy to be here today learning. Excellent, excellent. Well, I've got some good stuff for you today. We're going to talk about insider threats. And, well, insider threats have been around about as long as insiders have, so this is nothing new for us. Let's take a moment and just acknowledge how rarely, as an ICS community, we even talk about insider threats. These threats tend to be more dangerous than IT-related threats, and we're going to look at a couple of quick examples here. So there was one instance from the early 2000s. Again, this is nothing new for us. There's a location in Australia called Shire. I just like saying that name. And what happened with these folks is they had an employee who had been there for about 2 years. He had set up the control system for the sewage pumps, got into a disagreement with his boss, ended up leaving the organization. He then went and accessed the sewage control system remotely, and this guy released 800,000 liters of raw sewage into a river and a public park. So these are the types of things we're talking about with insider threats. The damage can be catastrophic. There's another great example that I personally went through. Who remembers the days before we had Wi-Fi at work? We had Wi-Fi at home way before we had Wi-Fi at work. So there was a gentleman, this is in Western Canada, and he wanted to be able to work more efficiently in the office. So he thought it would be okay to bring in his Linksys router from home and simply plug it into the work network, right? This guy figured he knows how networks work. You plug in the internet there, and we can get wireless. So he did this on his own without talking to anyone. And what had happened is he had inadvertently connected his router to the Wi-Fi, which was now accessible to a hotel across the street. So people in the hotel were going to connect to the hotel Wi-Fi. They ended up connecting to his Wi-Fi, and as a result, a bank had dozens of rogue users inside their environment. Great example of shadow IT, right? This is something we've been dealing with for a very long time. Nothing new to us at all. So let's start off and understand what is an insider threat. These are very different than your typical external threats. An insider threat is defined as a current or former employee, contractor, vendor, or other individual with legitimate access who causes a security incident. When you look up there, do those look like your typical insider threat? This is the challenge. Insiders are very difficult to spot. The threats are even harder to recognize. And unlike IT, we don't see a bad guy with a ski mask trying to walk through a door. These are very difficult to uncover. Interestingly enough, we have some good data behind insider threats. What we learned is that negligent employees and contractors account for more than half of the incidents out there. If we add compromised insiders, we find that only about a quarter of incidents are maliciously motivated. That's not a lot. So nearly 3/4 of the things that happen, we've got to be able to spot them. And we've even got some costs that we've been able to pin down based on this. So from a negligent employee or a contractor, those represent about 56% of insider threats. The average cost to deal with a negligent employee threat is around $485,000 American. So that's a big number here for us. As we look at malicious insiders, those represent about a quarter of all the incidents. And the cost of an incident goes up for a malicious insider. That's now closer to $650,000 US per incident. This is the cost to the organization. The most costly type of insider threat is from a compromised insider. These are things like shared passwords being compromised or hard-coded passwords on legacy systems. Compromised insiders represent the smallest percentage of insider threats, with only 18%, but the cost of a compromised insider incident is now approaching $800,000 US per incident. So the cost of these is going up, and the complexity to detect them is also increasing. So we've got a few different types of insider threats. We've got the negligent insider, right? This is somebody that this mistake is purely human error. This is somebody who is careless, they're distracted, they're impatient, and they inadvertently cause direct harm or expose the organization to an external attack, right? Unfortunately, we have to deal with people like this all day long, and they are a huge factor when it comes to IT security. The second type of insider threat is a compromised insider. This is someone who has their credentials stolen, or someone that is unwittingly the victim of a phishing campaign or some type of hacking attack, social engineering, the good old USB left in the parking lot, right? That still happens. We have a lot of people that unfortunately end up plugging things into their machines that they shouldn't. And you can unknowingly expose your organization to external attacks from this. The last type of insider is the malicious insider. And these are people that display unusual, unexpected, or unauthorized behavior. Now, the good thing is, when it comes to malicious insiders and that unusual or unexpected activity, these are things that we can track these days. We have the tools that let us do this. We can see unauthorized remote access attempts, right? We've got tools that can do that today. We can tell if somebody has accessed privileged systems or privileged data. We've got audit logs of that. We can now understand user behavior. So if users start logging in at odd times or from different locations, we've got the tools that can help us with that as well now. Things like software installations, large file transfers. Again, these are all common tactics used by a malicious insider that we can spot these types of trends. And of course, data exfiltration, right? We now have pretty good tools to help us understand if our data is being exfiltrated. Additionally to that, the malicious insider generally knows how to misuse the system. They're already trained on this. They are an insider. By nature, they understand what's going on. And the worst thing about the malicious insider is they're motivated by either revenge or personal gain. So this is not accidental. These are very intentional types of incidents. Insider threats in IT environments tend to have less of an impact than in an OT environment. And I'll give you a great example. If you take any large organization out there, if their mail server is compromised or a mail server goes down for an hour, there really isn't a business impact. It's nice for us when your phone stops blowing up for an hour, but ultimately the business doesn't stop operating. Whereas if you are a petrochemical facility or an airport or a power generation plant, if that plant has a system go offline for even an hour or even a minute, we've got some clients that operate environments where if someone hits the emergency stop button, it takes 3 months and $10 million to bring that plant back online. These types of things have a material impact to things like the stock price of your company. This is huge. People's jobs are on the line at this point. Somebody will lose a job when these type of incidents happen. So there's much more importance that we need to put on this type of thing. And again, particularly if you're in a very large process automation environment. The more automation, the more control systems, the more complex the environment is, the more costly in time and money to get back online. There's a few reasons why ICS environments tend to have bigger consequences and a larger impact. Number one, these are very people-porous landscapes. There's a lot of contractors, vendors, technicians, employees. There's a lot of people hanging around these places. The exposure is inherently larger. When you've got that many people coming and going into these critical environments, it's much harder to track. Again, along with people-porous environments, there's frequent shift changes, right? It's not uncommon for our largest customers in critical infrastructure to be operating 24/7. As a result, there can be hundreds or thousands of workers coming in and out every shift. Each one of those represents a potential threat vector. When you have that many people coming in and out, it's impossible to know everybody. So a lot of these people tend to be unknown, even if you've been there for months or years. It's not uncommon for you to be an unknown face. All you really need is a badge to get into a lot of these places. And it's not that difficult to either steal a badge, make a badge, or clone a badge. Again, unfortunately, we have this technology today. As much as this technology helps us as the good guys trying to fight cybercrime, we also have to remember that the bad guys have access to these same sets of tools to help them be even better at being bad guys. So people-porous landscapes is a big problem. Number two, in the OT world, we tend to talk about physical breach versus a data breach. In the IT world, it's all about protecting the data. In the OT world, it's all about protecting the process. Production downtime, we just talked about this. Unexpected downtime of OT environments is extremely costly. Not only that, these environments are prone to potential equipment damage. Can you imagine how much an oil refinery costs or a petrochemical plant? When these components get damaged, again, it's millions of dollars and can be months to get things fixed. Biggest thing is there's safety consequences. In IT, when a server goes down, the chances are very, 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 very low that anyone's going to get injured. In the OT environment, when systems go down, there is a very high likelihood for human safety to be compromised. So again, we've got to treat these systems very delicately. Not only that, like the example we talked about earlier, environmental damage, right? Whether it's sewage or a petroleum byproduct or a gas, the environmental damage can be catastrophic. And of course, when we talk about these complex environments, the time to recover is a killer. These are the things that, again, can do things like impact the stock price of an organization. If your flagship plant has been ransomwared and it's down for 4 months, this is a big problem. There's a couple of other key threats we want to talk about when it comes to OT networks. Number three, insiders generally have knowledge of key vulnerabilities. Again, that was their job at one point, to protect the weak spots. Now, as a threat actor, they have knowledge of what those weak spots are. They know how to gain access to sensitive control systems. They know how to navigate the infrastructure and exploit the weaknesses. And they know where there's insufficient monitoring or segmentation. So they've already got the playbook for how to cause mischief. And the last thing with respect to insider threats in industrial environments is it's really easy to steal credentials. Unfortunately, when we're talking about critical infrastructure environments, the average age of the equipment in these environments can be between 10 and 20 years old. That's not uncommon at all for us to walk into an environment and find customers that have been using infrastructure that is more than 10 years old. The challenge with that, as we all know, a lot of these systems tend to have things like hard-coded passwords. There's nothing you can do to change that. When people start leaving, they still have knowledge of those credentials. It's very difficult to change them, if not impossible. So we've got to be very aware of that. Additionally, people that work in OT environments, OT operators, these people don't have IT backgrounds. They're not technology savvy. They're not computer savvy like you and I are. So as a result, there's additional challenges. We see passwords written down on monitors, right? Passwords on stickies under a keyboard. These are all major problems that can lead to insider exploitation. There's a lot we can do, though. It's still challenging. There's a number of challenges when it comes to mitigating these things. A lot of the solutions are heavyweight and disruptive. And I'll give you a great example of that. In the IT world, we look forward to patching every Tuesday. Microsoft gives us a list of patches that we can execute automatically every single Tuesday if we want. Again, in the OT world, it's not uncommon for us to engage with a customer and find out that their next change window at a facility is in 2026, in March, when they're closed for the entire month to do a turnaround. So often, even if vendors, even if OEMs, even if software providers are issuing patches on a regular basis, that doesn't mean we can put them in the OT world. Again, the disruptive nature, needing a reboot on a system. We've got a contest internally at work to see who can find devices that have the highest uptime. And we found stuff that's in the thousands of days, tens of thousands of days of uptimes for some devices. So that means you cannot reboot, you can't do a code upgrade, you can't apply a patch. Pulling down a switch can impact a larger process, which means a 2-month turnaround. So we've got to be very careful with these. They're heavyweight and they're disruptive. Another big challenge, which we have started to come around to, and a few of you in the room will be able to relate to this, is we've got to the point where we now have accepted that you can't use IT tools to solve OT problems. This has been tried for a decade and a half, if not longer. And we are finally getting to that realization point that we do need specific tools that understand OT environments, that are able to provide threat detection and threat mitigation in a way that IT tools simply can't do. There's dozens of examples of this, from things like port scanning, right? Very commonly used tactic in IT environments to discover vulnerabilities. That works great on servers and PCs and workstations. However, in the OT world, these devices are built differently. Things like programmable logic controllers, HMIs, IEDs, relays. These devices aren't built to handle that type of probing. And as a result, we have a number of instances where people have had catastrophic outages and failures from simply pointing port scanning tools at industrial devices. So again, this is a big challenge. We finally have reached the capitulation point to understand that we can't use IT tools to solve OT problems. Another big challenge are things like a SIM. SIM is an amazing tool and required and necessary in every environment. You need to log things. You need to be able to correlate data points together. The challenge with most SIMs is that they will often take 30 to 60 minutes to correlate all of those incoming logs and actually issue an alert. By then, it can be too late. Imagine if you're a nuclear generation facility or a hydro dam or an airport or a shipping terminal. We don't have 30 to 60 minutes to be alerted that something's going on. So we really need to have something that can provide us with that network-based detection and endpoint-based detection that talk together and share information. We know that endpoints tend to be the most used threat vector to get into OT networks. Whether it's an IT endpoint or an OT endpoint, endpoints are generally ground zero for the infection. The good news is we do have new tools that are OT specific. We now do have endpoint sensors that can help us understand what's happening on these industrial devices. Traditionally, there's been no way for us to correlate what's happening on the network with who's driving it. We've been missing that user correlation. We now have tools that can tell us, hey, it was this person from this machine uploading this file to that PLC, and that happened right before things started going south. So we can now stitch this together. User and activity correlation is something that's been missing. We've been doing this in IT forever. We've got agents all over the place that can tell me exactly who's logged into a machine and exactly what commands they may be running through. On the OT side, we've been missing that. Now that we do have something that we can install on an endpoint that provides a level of visibility, we can do things like we can now detect a malicious insider. I can see if somebody is issuing malicious commands to an industrial device, and I can tell you exactly who that person was. When we have third-party contractors coming in to locations, we can now detect and mitigate before malware gets on the network. Of course, we can't overlook things like operator error. This is always going to happen. People make mistakes. People these days are overworked and underpaid, and humans have always been prone to error. We can catch that now. We can catch accidental configuration changes made by people on the network. So we have the ability to look before traffic even hits the network. We can start spotting threats. And of course, things like stolen credentials. I can now correlate what's happening on a machine, when it's happening, and we can apply some logic to that. And I can say, hey, wait a second, why is Mark logging into this machine when he normally does that 8 hours later, and this location is 3,000 miles away from where he normally logs in from? So we've got tools now that can help us spot credential misuse and stolen credentials. We do have some strategies, though. There is help out there. There's a lot of tools that we can use that are specifically tuned for these environments. Here's a list of several of them. Of course, it's going to be impossible for every organization to implement all of these, but the more you can have, the better posture you will be having at defending threats. The first line, which is actually not even that great anymore, is physical access, things like badges. We talked about this, though. Badges can be shared, badges can be stolen, badges can be cloned. Badges are easy to get around. So from a digital defense perspective, we really start at phase 2 here, which is digital access credentials, monitoring access credentials, tracking credentials, being aware of things like password reuse policies and different password complexity strategies. These are all things we can do to make it tougher. The next thing, and we've been doing this for a very long time in IT, we're just starting to do this in OT, is real-time network monitoring. Traditional IT tools, again, don't have the ability to understand or decode or decrypt or parse OT protocols and OT messages. So we now have great tools that can provide us with real-time monitoring for OT networks. The new addition to the family, obviously, is real-time monitoring for OT endpoints. Like we just talked about, the ability to now understand what's happening on an endpoint instead of just relying on what's happening on the network. So again, the more of things you can use, the better. We've got network monitoring, we've got endpoint monitoring, and now there's something that I love talking about all the time. Again, something we're very mature with in the IT world, but we're very lacking in the OT world, and that's segmentation. Show of hands if you've ever been kept up at night having to write a segmentation paper for your manager. Segmentation, everyone's favorite topic. We need to be more disciplined when it comes to segmentation. In OT networks, we have a concept called the Purdue Reference Architecture, IEC 62443. Anyone in the room familiar with that? Perfect. Purdue architecture is a standardized reference architecture for OT networks that includes segmentation. We want to keep sensitive devices segmented away from insensitive devices. So we've got lots of models, lots of architectures to help with that. However, again, talking about networks that are 10 years old, 20 years old, these tend to be flat environments. I mean, still often enough, we will walk into an environment, I'll walk into a petrochemical facility and find out that they've got printers and computers on the same network as their industrial devices, just amplifying your threat vectors. So segmentation is a very important part of security overall, and something we spend a lot of time helping our customers get towards. Now things start to get cool with things like AI. I'm sure you've heard the word AI many times today and over the past several years. One of the things we've been doing at NOZOMI is we've actually been using AI for 11 years now. Our founder has a PhD in artificial intelligence, so we've been using this since day one inside the product. AI for us is helping us understand behavioral analytics, how these devices should behave. Because in order for me to tell you something is not working well, we first got to understand what good looks like or what normal looks like. And to every single person in this room, good is going to look a slightly different way. So we've been using AI and behavioral analytics to learn how devices operate under normal working conditions in your environment, and then it becomes very easy to spot when things start to go sideways. The last thing that's critical in securing OT environments, and again, we've got a ton of experience with this in IT, is having an incident response plan. We already know in IT what to do if somebody on their laptop gets a piece of malware. There's a sequence of events. The help desk can tell you, do this, 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 and this. We've had that for a while. One of the big challenges is understanding incident response plans for OT. They're very different. In the IT world, an incident response plan could be as simple as, why don't you hit Control-Alt-Delete? Perfect. I can reboot my laptop all day long with no impact to the business, but I can't do that with a lot of critical automation systems. So again, we have to have an incident response plan that allows us business continuity, but at the same time, without compromising any of the safety. So there's a few key takeaways from this, and of course, we would love to talk more about this. We're at booth 714 in the other end of the room there. If anybody is interested, we would love to continue this conversation, but in the meantime, there's three key takeaways. Number one, ICS insider threats are real. They're happening. And the consequences are massive. So we've got to be aware of that. Number two, ICS-specific problems require ICS-specific solutions. Make sure the tools you're using are compatible and comfortable operating in OT environments. And the last thing is that network and endpoint detection are critical, and it's critical that those two systems work together, because otherwise time to respond, time to detect gets larger, and the more time that bad actors have in our environments, the more damage they can do. And with that, I want to thank you very much for your time this morning. It's been wonderful to be here, and I hope to see you guys at our booth later on. Thank you.
Thank you.